Hello everyone, this is Niharika from Sri Venkateswara College of Engineering, and this is my subject data structures. Let us move on to our topic structure and union. Stack, push and pop, queue, insert and delete, linked list, insert and delete. Let us learn one by one. Structure and union. In computer science, a structure is a composite data type composed of multiple elements that may be of different data types. It is often used to group related data together. On the other hand, a union is special data type available in C language that allows storage of different data types in the same memory location. The main difference between the structure and union is that in a structure, each member has its own storage location, whereas in union, all members share at the same storage location. This difference leads to a different use cases and memory allocation strategies for each. Let us see some differences between structure and union. In structure, the keyword struct is used to define a structure. In union, keyword union is used to define a union. When a variable is associated with a structure, the compiler allocates the memory for each member. The size of the structure is greater than or equal to the sum of the sizes of its members. In union, when a variable is associated with the union, the compiler allocates the memory by considering the size of the largest memory. So, size of union is equal to the size of largest member. In structure, each member within a structure is assigned unique storage area of location. Here in union, memory allocated is shared by individual members of union. Here, value altering. In structure, altering the value of member will not affect other members of the structure. In union, altering this value of any of the member will alter other members' value. Accessing members. Individual members can be accessed at a time. In union, only one member can be accessed at a time. Initialization of members. In structure, several members of a structure can initialize at once. In union, only first member of the union can be initialized. Let us move on to what is stack. A stack is a linear data structure in which the insertion of a new element and removal of an existing element takes place at the same end represents as top of the stack. Here you can see a picture of stack. Top push item and removing this pop item. Here basic operations on stack. In order to make manipulation in a stack, there are certain operations provided to us. Push, pop, top is empty and size. Push, which is used to insert an element into the stack. Pop is to remove an element from the stack. Top, which returns the top element of the stack, is empty means returns true if stack is empty, is false. Size returns the size of the stack. Let us see stack push and pop. Push. The push operation is used to add an element to the top of the stack. When an element is pushed onto the stack, the size of the stack increases by 1 and new element becomes the top of the stack. And pop. The pop operation is used to remove an element from the top of the stack. When the element is popped from the stack, the size of the stack decreases by 1 and the top element is removed. Let us study what is queue. A queue is defined as linear data structure that is open at both the ends and the operation are performed in first in, first out, FIFO order. Here in queue, front end, which will remove an element from the front end, and in rarer end, the element is added. In the element stored at the front end, first element is stored at the front end and the last element is stored at the rear end. Here we can see queue, the name of the array storing queue elements. Front, the index where the first element is stored in the array representing the queue. And rear, the index where the last element is stored in an array representing the queue. Let us learn the queue insert and deletion operation. Insert operation adds an element to the rear end of the queue. Delete. Deletes operation removes an element from the front end of the queue. Let us move on to what is linked list. Linked list is a linear data structure which looks like a chain of nodes where each node is different element. Unlike array, linked list elements are not stored at the contiguous location. There are three types of linked list, that is singly linked list, double linked list and circular linked list. Let us learn one by one. Singly linked list. It is a simplest type of linked list in which every node contains some data and a pointer to the next node of the same data type. Let's see the doubly linked list. A doubly linked list or a two-way linked list is a more complex type of linked list that contains a pointer to the next as well as the previous node in sequence. You could see in the picture. In circular linked list, the circular linked list is a linked list where all nodes are connected to the form of a circle. In a circular linked list, the first node and the last node are connected to each other, which forms a circle. There is no null at the end. You could see in this picture that first element, first node and the last node is connected. And to the first node to the second node, there is a connection like this. The connection between second node to third node to fourth node. This is called as circular linked list. Let us see linked list with insertion and deletion operation. Insert. The insert operation adds a new node to the linked list at the specified position. Delete. The delete operation removes a node from the linked list based on the specified position or value. Implementation of structure and union. Structure implementation. Structures are often implemented using class and objects in object-oriented programming language like C++. Union implementation. Unions are typically implemented using a specific syntax provided by a programming language like C and C++. Implementation of stack, push and pop. Push. The stack implementation involves adding a new element to the top of the stack. Pop. Stack implementation involves removing a top element from the stack. Implementation of queue, that is insert and delete. It needs a storage, pointers and memory management. Implementation of linked list. Insert and delete. Insert. Linked list insertion involves updating pointers to include the new node in the list. In delete, linked list deletion requires updating the pointers to remove the node from the list. Thank you for watching my video.